Hello and welcome to another integration example. So looking at this problem, it looks messy and ugly. Um, so to determine if U substitution is going to be a way to go, the first thing you should look at is find an inside function. And this is just a general rule. It's not won't always work, but my inside function is 4 minus 3x to the fifth. If you think about what the derivative is going to be, it's going to differentiate down to something times x to the fourth, which is what we have up here. That usually means it's a very good candidate for U substitution. So that's something to look for, and it's something you'll probably see automatically as you do more and more of these things. So it's going to get really obvious as you're practicing. So I'm going to let U then be the inside function. Now that's going to take care of this piece. Now remember, when you use U substitution, everything has to be in terms of U. So including the dx. So that's a really good case for this is why we have to figure out what du is, because that's the only way to bring a dx in. So the differential of U, du, is the derivative of U, which would be negative 15x to the fourth times dx. So in order to get the integral completely in terms of U, well, we already have that as U. The fifth root is fine. We're going to take care of that with the integration. The other thing we need to worry about is the x to the fourth dx. And you can think of this as x to the fourth times dx. Well, x to the fourth times dx is right here. So what I usually do then is just solve. X to the fourth dx would equal du divided by negative 15. And then I'll prefer just to, instead of saying du divided by negative 15, I'll say negative 1/15 du. You'll see why when we make the substitution. So let's make the substitution. I'll start with the bottom. I'll start with my u. We said 4 minus 3x to the fifth is u. That was a straight substitution. X to the fourth dx up here is negative 1/15 du. So remember, negative 1/15 is a constant. Du is not, but we need that. That's like our integral with respect to u. So when you're integrating, you always have to be able to use the power rule if you have an algebraic function, which is you need to get anything in this form or the sum difference of this form. And this is perfect because we can use our rules of exponents and write this as u to the negative 1/5 du. And then the integration becomes easy. It's just adding 1 and multiplying by a reciprocal, which it always becomes with algebraic functions. So we're going to add 1 and multiply by 5/4. So 5 and the 15 will cancel out to become 3 on the bottom. So this is negative 4/3 plus c. But I'm not going to write my plus c yet because I still have a little bit of work to do. I need to plug u back in. We said u is 4 minus 3x to the fifth. So we have 4 minus 3x to the fifth. And that should be integral. Now, to check it, you would take the derivative of this and make sure you get the original function, which is right here. I shortcutted it and I just plugged it into Wolfram Alpha. Hopefully that is a match. Uh-oh. Something went wrong. Oh, that was dumb. Okay, so this is why it's important to check. So I could edit this out, but I'm not sure how to. So we're going to have to deal with this. Hopefully you saw what I did as I was doing it. It was constant trouble. So I had, at this point, I had negative 1 over 15 times 5/4. I said 3 was on the bottom, I think, but so is the 4. So maybe I should have written it out. So this constant should have been negative 1/12. So better take my eraser so make this neater. That just shows you the importance of the check. And if you tried to take the derivative of my original answer, it definitely would not have checked. But there you go. Now it's correct. Thank you, Wolfram Alpha. I'll try to do better on the next one. Stick with me.